Welcome back, everyone. This is Gurpreet Sikh on this side, and we were doing the logarithmic differentiation of NCERT 12th Mathematics exercise 5.5, and we have done the example, still example number 32. We are only left with example 33, and with this, we'll be completing this exercise. So in the previous three examples that I have explained you in the previous videos, there were functions which were only involving x, but in this there is the function in which y is also involved. So just you cannot write the whole function is equals to y, and literally you cannot, because there is an equal to also involved in the equation. So there is a different method that is not completely different, but it will also include logarithmic differentiation. So don't worry about that. Firstly, suppose this is equals to u, this is equals to v, and this is equals w. So firstly write this. Let y raised to power x is equals to u, and x raised to power y is equals to v, and x raised to power x is equals to w. So just change the equation. You will get u plus v plus w is equals to a raised to power b. What you have to find dy upon dx, it means differentiate the whole equation with respect to x. You will get du upon dx plus dv upon dx plus dw upon dx, and this is constant raised to power constant, so it's a constant term, its differentiation will be 0. So indirectly we have to find du upon dx, the differentiation of u with respect to x, the differentiation of v with respect to x, and the same of w with respect to x. So we will be differentiating u, v and w separately, and then we'll add the result and we'll find dy upon dx. So firstly, what is u? U is y raised to power x. It is the same logarithmic differentiation that we have been using in the previous three examples. So firstly, take log on both sides. Log of u is equals to log of y raised to power x. Simplify it a bit. Log m raised to power n, that is n log m. Okay, and this is log u only. Differentiate with respect to x. I am using this much space only because I will solve the second function here and third here for the clarification. So differentiate with respect to x the whole equation, of course. You will get d dx of log of u is equals to d dx of x log y. Clear? Now log of u, it will equal to 1 upon u du upon dx. Clear? And here we will apply u multiply v. You will get x, and what's the differentiation of log y? That is 1 upon y. And don't forget, y will be again differentiated with respect to x. So you will get dy upon dx. Clear? Then plus v, that is I am applying the identity of u multiply v. Then v, what is the differentiation of x with respect to x? That is 1 only. So you will get only 1. So ultimately you will get your du upon dx is equals to x upon y dy upon dx plus log of y, and when this u will be multiplied to this side, fill in the value of u, that is y raised to power x. This is what we get after the differentiation of u. Now we'll do the same thing with v. What is v? That is x raised to power y. Firstly, take log on both sides. Be quick with your steps because it's a lengthy sum. Log of v is equals to log x raised to power y. Simplify it a little bit again. That is log m raised to power n is n log m. Now differentiate again the whole equation with respect to x. You will get differentiation of log of v on the left hand side, and differentiation of y log of x on the right hand side with respect to x. So what's the differentiation of log of v? That is 1 upon v dv upon dx, and here we will apply u into v. Then u, what's the differentiation of v? What's the differentiation of log x? That is 1 upon x, and what's the differentiation of x with respect to x? Again 1. So plus v, and what's the differentiation of y with respect to x? That is dy upon dx. What will you get? dv upon dx equal to y upon x plus log x dy upon dx. Put inside the bracket, and when v will be multiplied by the bracket, fill in the value of v, that is x raised to power y. Okay, clear? Now W is remaining only. W is equals to x raised to power x. Again, take log on both of the sides. Log of W is equals to log x raised to power x. Now, simplify it a bit. Log of W is equals to log m raised to power n, that is n log m. Clear? Now, differentiate with respect to x. What will you get? Differentiation of log of W with respect to x, which is equal to differentiation of x log x. Now solve it. You will get 1 upon W dw upon dx is equal to u multiply v. Of course, the identity will be the same. U differentiation of v, that is 1 upon x, plus v differentiation of u. Now x, the differentiation of x is 1. So you will ultimately get dw upon dx is equals to, now x will be cancelled. You will get 1 plus log x. W when it will be multiplied by this bracket, fill in the value, that is x raised to power x. Now you have get all the three results which were required to find the dy upon dx. Now just put these results in equation 1. Use these results in the equation 1. So du upon dx plus dv upon dx plus dw upon dx. Now add all these results. You will get y raised to power x, x upon y, dy upon dx plus log of y. We have filled the value of du upon dx. Clear? Now plus dv upon dx, that is x raised to power y, y upon x plus log of x, dy upon dx. dv upon dx is also done. Turn of dw upon dx, x raised to power x, 1 plus log of x. And what is it equal to? That is equal to 0. Now we will be finding the value of dy by dx, but this is very clear in the equation that dy by dx has to be separated out. So firstly, multiply this inside the brackets. You will get y raised to power x into x upon y dy upon dx plus y raised to power x log of y. Clear? Multiply this, x raised to power y multiply y upon x plus x multiply y log of x dy upon dx. And we don't have any need to multiply this inside the bracket because there is no dy by dx included. So it will remain as such, x raised to power x 1 plus log x is equals to 0. Now it's y raised to power 1 and it's x. When it will be shifted to the numerator, it will become minus 1. So the whole power of y will be x minus 1. You will get y raised to power x minus 1 multiply x dy upon dx plus y raised to power x log of y. The same thing will go here only, as x, the power of x in the denominator is 1 and that in the numerator will become minus 1. So the whole power of x will be y minus 1 plus x raised to power y minus 1 multiply y plus x raised to power y log of x dy upon dx, and this will remain as such, x raised to power x 1 plus log of x is equals to 0. Now this includes dy by dx, this includes dy by dx. Now separate them. Take dy by dx as common factor. You will get y x minus 1 raised to power x minus 1 multiply x plus x raised to power y multiply by log x. Clear? From these both terms, we have taken dy by dx as the common factor is equal to, now take all the extra terms on the other side. Firstly this minus x raised to power x, because the sign will be changed because the term is being transposed, 1 plus log x minus y raised to power x log y minus y multiply x raised to power y minus 1. Clear? Now we will be finding dy by dx only. So this will be divided by this factor on the right hand side. Minus x raised to power x 1 plus log x minus y raised to power x log y minus y multiply x raised to power y minus 1, which will be divided by y raised to power x minus 1 multiply x plus x raised to power y, which will multiply by log x. This is our final answer because we had to find dy by dx only. With this, our exercise 5.5's examples are finished. It was actually a long example, but I'm sure and I'm very much confident that I have made it that much easier for you to understand it completely. Now, I am pretty much sure that you can do the sums of this exercise yourself. Otherwise, if you find any problem, don't hesitate in sharing it with me in the comment section. And we are done with the examples of 5.5 exercise with this. So before leaving, just don't forget to press the subscribe button to subscribe my channel and the bell icon as well, so that you will get the regular updates of my channel. Thanks for watching. Keep practicing your mathematics and best luck with the practice.